Let's look at the solution of modern maths bites. For a scholarship, at most n candidates out of 2n plus 1 can be selected. If the number of different ways of selection of at least one candidate is 63, the maximum number of candidates that can be selected for the scholarship is. Okay, look at this. We have 2n plus 1 C1 plus 2n plus 1 C2 plus 2n plus 1 C3, so on and so forth up until 2n plus 1 Cn. This is what is told to us. Now, the beautiful thing that you can see is we know 2n plus 1 C1 or 2n plus 1 C0 plus all the way up till 2n plus 1 C2n plus 1. This entire thing should be equal to 2 raised to the power 2n plus 1. This should be equal to 2 raised power. So the above expression that we have, it is missing two parts. The first part it is missing is, let me use a different pen. The first part it is missing is 2n plus 1 C0 and everything else that would come here 2n plus 1 Cn plus 1 all the way up till 2n plus 1 Cn plus 2n plus 1, this much. Hopefully we also know that the extremes are equivalent. So up until this point, what you would have is half of the total. So this part is going to be 2 raised to the power 2n plus 1 by 2. This part is going to be 2n plus 1 divided by 2. Yet all that we were told was that this is equal to 63. We know this is equal to 1. So can I go 2 raised to the power 2n plus 1 by 2 is equal to 64, 63 plus 1, or 2 raised to the power 2n plus 1 is equal to 128, or n is equal to 3. And this is what precisely the question was asking me. The maximum number of candidates that can be selected for scholarship is n candidates. N is equal to 3. Answer to the question will be 3. A bag contains 6 white and 4 red balls. 3 balls are drawn one by one with replacement. If the probability that out of the 3 drawn, 2 balls are white and 1 is red is given by P by Q, where P and Q are co-prime, find Q minus P. Okay. So we are taking out 3 balls with replacement and 2 are white, 1 is red. This can be done in 3 ways: white, white, red, white, red, white, or red, white, white. Probability wise, the measure of this case and this case and this case would be same, because anyway we are replacing. So I can cumulatively write it as 3 into 6 by 10 into 6 by 10 into 4 by 10. Okay. So if I cancel and cancel, I get 3 and 3. This would turn to 5. This would turn to 5. This will again turn to 5. This will turn to 2. So 3 into 3 into 3 is 27. 27 into 2 is 54. And 5 into 5 into 5 will be 125. And these two are co-prime. This is the simplest form of the ratio. Finally, we were asked find Q minus P. So 125 minus 54 we have to do. The answer to the question will be 71. Next, a 5-letter word having distinct letters is formed using the 5 letters COIWT. All such possible 5-letter words are written in an alphabetical order from CIOTW to WTOIC. What will be the 60th word written? Okay. I can see this. This is the smallest letter, or alphabetically the earliest letter. This is the second one. This is the third one. This is the fourth one. This is the fifth one. Okay. So if I fix C at the beginning, the remaining 4 letters can come in 4 factorial or 24 ways. If I fix I at the beginning, The remaining 4 letters can come in 4 factorial or 24 ways. O would be the next case, and O is what I want, because if I do 24, 24, 24, I will cross the threshold of 60. I just need till 60. So the next case I see is OC. This will come in 3 factorial 6 ways, and next would be OI. Again, 3 factorial 6 ways. This is wonderful. I've already reached precisely the 60th term that will get created. So there are 2 ways to think here. One, the only option that has OI in the beginning is option C. So that will be the answer. Another way of thinking is, given that we are going up until the last term here, ideally what should happen is the 3 terms that are left, the 3 constituents that are left, they should be in reverse alphabetical order. So you would have W, T, and C here, which will then lead you to option C. In either case, answer will be option 3. Next, a dice is rolled 3 times. Find the probability of getting a number which is at least 2 more than the previous number each time. Okay. First case I can see is 135. Another case I can see is 136. Another case I can see is 146. And the last case I can see is 246. Because see, the problem is if you have n plus 2, and n plus 4, even if you had a gaps of exactly 2, you will need to have gap of 4 between these 2 numbers. And given that the largest number cannot exceed 6 and the smallest number cannot be less than 1, these are the only cases that will get created. So you have 4 acceptable cases out of die being rolled 3 times. So 6 cubes, so 216. So this will be equal to 1 by 54 or option A. Last question. In the month of January, what is the ratio of probability of someone's birthday falling on a date that is a prime number to the probability of the birthday falling on a date that is a perfect square of a prime number? It is known that birthday falls in the month of January. Okay. So I'm looking at this second number. We need the ratio A by B. I'm focusing on B. Perfect square of a prime number up until 31. There are only 3 possibilities, 4, 9, or 25. So do we know we will have something by 3? We will have something by 3. So denominator as 4 is impossible. Denominator as 11 is impossible. Answer has to be option B. You don't even have to engage in the hard work of finding out what is the value of A. You can get to option B straight away. In case you want to calculate it, let's count prime numbers up until 31. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. So 3, 3, 3, and 2, 11 you would get. Then you would reach your answer B 11 by 3. In either case, what I wanted to showcase was in this question, even if you did only the second number, you would reach your answer. That will be all for this Modern Maths Bites. Hopefully you learned something.